Hi everyone, welcome back to Beginning Algebra. Today we're in section 5.6 talking about special products. Now we learned in the last section how to multiply a binomial times a binomial using the FOIL method, but there are some binomial multiplication problems that follow a particular pattern, and instead of using the FOIL method we can take a little shortcut to the answer if we recognize the pattern. So today I'm going to show you how to square binomials, and we'll also talk about how to find the product of a sum and difference of the same two terms. Let's go ahead and jump in. Now, as I said before, all the problems in this section can be worked using the FOIL method that we learned in the last section. But it's always nice to have a shortcut, and certain types of problems will produce answers that we can get by shortcut if we recognize the pattern. Now, sometimes students want to just ignore this because they'll say, look, I already know a way to work this problem. I don't really need a shortcut. But knowing these patterns will save you a lot of time later on. So I really want to encourage you to spend a little time learning the patterns now so that you can save a lot of time later on. It really is worth it to learn these two shortcuts I'm going to show you. Let's start by looking at some binomials that are being squared, and then we'll work them out using the FOIL method and look at the answers and see if we can come up with the pattern ourselves. We'll start with x plus 3 to the second power. Of course, you know that that would be x plus 3 times itself. And now if we use the FOIL method on this, first times first is x squared, outer times outer would be 3x, inner times inner would also be 3x, and then last times last would be 9. The terms that we got from outer and inner are like terms, so we can combine those, so we'll end up with x squared plus 6x plus 9. Let's get another one to compare with. So here I have x minus 5 to the second power. That would be x minus 5 times itself. So first times first again would be x squared. Outer times outer would be minus 5x. Inner times inner would also be minus 5x. And last times last would be positive 25. Combining the two middle terms, we're going to end up with x squared minus 10x plus 25. Let's get one more. Here I have x plus 6 squared, so that's x plus 6 times itself. Using the FOIL method, we're going to get x squared plus 6x plus 6x plus 36. And then the two middle terms combine and give us x squared plus 12x plus 36. Now I want us to look at these three answers and look back at the problem, and let's see what we can determine about these patterns. So if you look at the first times first, each of these first times first terms was gotten by multiplying the first term times itself. And of course, each of these last terms was obtained by multiplying the last term in the parentheses by itself. 3 times 3 gave us 9, 5 times 5 gave us 25, 6 times 6 gave us 36. But the only thing that might not be obvious at first is where did the middle term come from? Well, notice that you can produce this middle term each time if you take the first term times the last term, multiply them together, and then multiply that by 2. So in this case, 3 times x would be 3x, and 3x times 2 would be 6x. Let's see if that works here. Negative 5 times x would be negative 5x. Multiply that by 2, you get negative 10x. And on the last one, 6 times x is 6x. Multiply that by 2, you get 12x. And so I think you probably are starting to see how we can get to the answer just by looking at the problem. Let's try to square these binomials using the pattern instead of writing out the FOIL steps. So we'll say x times x is x squared, and then for the middle term we'll say 9 times x is 9x, 9x times 2 is 18x, and then last times last is 9 times 9, so that's going to be plus 81. Try it again on x minus 8 squared. So first times first would be x squared. For the middle term, we'd have negative 8 times x. That's negative 8x. Then we multiply that by 2. So negative 8x times 2 gives us negative 16x. And then for last times last, we say negative 8 times negative 8. That's positive 64. And for the last one, we have 3x plus 2 squared. So to work this out, we'll say 3x times itself. Now 3x times 3x is going to be 9x squared. For the middle term, we have 3x times 2, that's 6x, and then we multiply that by 2, so the middle term is 12x. And then for last times last, we have 2 times 2, which is 4. And now I guarantee you that if you went back and multiplied each one of these out using the FOIL steps, you'd get the same answer, but you'd just do a lot more work to get it. So you probably have a pretty good handle on the steps that we used already, but let's go ahead and officially write them down so you'll have them for reference. So the first term in the answer is the square of the first term in the problem. The middle term is 2 times the product of the first term and the last term in the problem. And the last term in the answer is the square of the last term in the problem. Notice that the square of a sum will always have a positive middle term, and the square of a difference will always have a negative middle term. And for each one, last times last is going to be positive, because when you square a number, whether it was positive or negative, the square always is positive. So in example 1, we're just going to practice using that pattern. In part A, we have t minus 8 squared. So to work this out, instead of using the FOIL method, we'll just say the first term is t times t, that's t squared. To get the middle term, we'll say negative 8 times t, that's negative 8t. Then we multiply that by 2, and we'll get negative 16t. And then for last times last, negative 8 times negative 8 is positive 64. Let's try it again on part B. For first times first, we'll have 5z times 5z. That's going to be 25z squared. For the middle term, we'll have negative 1 times 5z. That's negative 5z. Then we multiply that by 2. That's going to be negative 10z. And then for last times last, negative 1 times negative 1 is positive 1. For part C, we say 3b times 3b is 9b squared. For the middle term, we say 5r times 3b would be 15br. And then we multiply that by 2. That would give us 30br. And then for the last term, we say 5r times itself would be 5r times 5r. That's positive 25r squared. Now, if you've not tried one on your own yet, I would encourage you to pause the video here and try part D by yourself. Now I'll go through it with you. So to work out 2a minus 9x all squared, we'll say 2a times itself. That gives us 2a times 2a, which is 4a squared. For the middle term, we'll say negative 9x times 2a. That's going to be negative 18ax. And then we multiply that by 2. That's going to be minus 36ax. And then for last times last, we say negative 9x times itself. That's going to be positive 81x squared. For part E, you might be a little worried because you see the fraction here, but don't worry, we're going to work this out together. It's not really a bad problem at all. So we'll still use our pattern. We'll say 4m times 4m is 16m squared. To get the middle term, we'll have to multiply 4m times 1/2. So since it involves a fraction, I'm going to write it down here. So we'd do 4m times 1/2. Notice that 4 divided by 2 is 2. So when I multiply these two together, I get 2m. And we know that the middle term is going to be this times 2. So that middle term will be 4m. And then for last times last, we'll have to do 1/2 times itself. And that would give us 1/4. So our last term is 1/4, and we end up here with 16m squared plus 4m plus 1/4. Now for part F, notice that we have a monomial, multiplied by this squared binomial. So what we need to do is work out the squaring first and then distribute the x. And that all goes back to order of operations. Remember, PEMDAS says that we have to handle exponents before we handle multiplication. So we need to deal with this exponent here before we multiply x by the rest of this. So I'm just going to keep the x here, and then I'll put a pair of parentheses and work out this 4x minus 3 squared. So we know that 4x times itself would be 16x squared. For the middle term, we'd say negative 3 times 4x is negative 12x, and then multiply that by 2, and we'd get negative 24x. And then for last times last, negative 3 times itself would be positive 9. Now we can distribute the x. So x times 16x squared would be 16x to the third. X times negative 24x would be negative 24x squared. And x times 9 would be positive 9x. Now we're ready to move on to our next shortcut. We're going to learn how to find the product of a sum and difference of two terms. Now this is a little different from squaring a binomial, because notice here we're talking about the sum and the difference of two terms. So this cannot be written as x plus 3 squared, because it's not x plus 3 times itself, it's x plus 3 times something else entirely. So let's try the FOIL method on this problem. So first times first would give us x squared, outer times outer would give us negative 3x, inner times inner would give us positive 3x, and then last times last would give us negative 9. Notice that when we add the outer and the inner terms, they're going to add up to 0, and our final answer just comes out x squared minus 9. And now let's look at x plus 5 times x minus 5. We'll notice that pretty much the same thing happens here. First times first gives us x squared. The outer is minus 5x, the inner is positive 5x, and the last times last is minus 25. So when we combine our two middle terms, they add up to 0. And let's look at one more. Here I have x plus 6 times x minus 6. So first times first gives us x squared. Outer times outer gives us minus 6x. Inner times inner gives us plus 6x. And last times last gives us minus 36. So we end up with x squared minus 36. So now look at the problems without the FOIL steps and compare those to the answers, and let's see what kind of pattern we can come up with. Notice that in each case, the middle term has added up to 0 and the last term is negative. So we always end up with square minus square. So again, the pattern is that the middle terms always add up to 0, and the answer is always a square minus a square. And for this reason, this type of expression is called a difference of squares. You know that the word difference means subtraction, and you know that a square is a second power. So when you look back at each of these answers, notice that they are all square minus square, and that's why they're called a difference of squares. So here in example 2, let's practice finding the product of a sum and difference of two terms using our new shortcut. So here I have x plus 4 times x minus 4. Notice that it does fit the pattern of being a sum and difference of the same two terms. So I can say first times first is x squared. I know in advance that the middle terms will add up to 0. And last times last is going to be negative 16. On part B, again, I notice that it fits the pattern of being a sum and difference of the same two terms, and that means I can use my shortcut. I can say 10 times 10 is 100. The middle terms will add up to 0, and last times last is going to be negative w squared. For part C, notice that we do have a sum and a difference of the same two terms, but we also have this x in front. So first let's multiply this sum and difference out. We'll keep the x in the front, and we'll say x plus 2 times x minus 2 is going to be x squared, middle term is 0, and then the last term is going to be negative 4. And then finally we can distribute the x, and get x times x squared is x to the third, and x times negative 4 is negative 4x. Here's example 3. This is pretty much the same thing. Part A would be a good one for you to try on your own. If you would like to pause the video and try it, I encourage that. And now I'll go through it with you. First times first would be 5m times 5m. Of course, that's 25m squared. Because this is a sum and a difference of the same two terms, the middle terms will add up to 0, and last times last will be minus 9. And here on part B, we have a sum and difference of the same two terms, but this time there are two variables involved. However, that does not change our pattern at all. We'll still use the same pattern. 4x times 4x will be 16x squared. Because this is a sum and difference of the same two terms, the middle term is 0, and last times last is going to be negative y squared. Here's one involving a fraction, but notice that it is a sum and a difference of the same two terms. So we can use our pattern. We'll say z times z is z squared. We know in advance that the middle term will add up to 0, and then negative 1/4 times positive 1/4 will be negative 1 over 16. For part D, we have a p in front of our sum and difference of the same two terms. So we'll keep that p in front for now, and let's multiply the sum and difference together. 2p times 2p will make 4p squared. The middle terms will add up to 0, and then last times last will make negative 1. And now let's distribute the p. So p times 4p squared is going to give us 4p to the third, and then p times negative 1 is going to give us negative p.